Welcome back. In this video session, I want to teach you about a coordinate system called the UTM Coordinate System. And UTM stands for Universal Transverse Mercator. So this cylinder where the globe touches the cylinder at the equator is the mercator projection. So if we flip the cylinder on its side, that's the transverse mercator projection. And then basically what we're going to do is work within a narrow zone of a 6-degree wide zone, which is a UTM zone. And then there's going to be 60 UTM zones to cover the globe. Okay, so each UTM zone is 6 degrees wide, and they're numbered starting at -180 is zone 1. And then 6 degrees wide, so zone 2 would be -174 to -168. So here's zone 2, which covers sort of the central Aleutian Islands. Zone 1 would cover from -180 east to -174, and then actually zone 60 is in Alaska. The eastern tip of the Aleutian Islands would be zone 60. And then we go all the way to zone 9 down in the Panhandle region of Alaska. Okay, so let's go back to our arc map example. We have our original 2 layers in longitude and latitude, and what we're going to do is create 2 new feature classes in the UTM coordinate system, which will be in meters. So we'll use the project tool. Okay, so we'll project our Alaska polygon from longitude and latitude into the UTM coordinate system in meters, and we'll project it into zone 1. So you remember zone 1 is from -180, 6 degrees wide, to -174. So we go to this button, and then we need to go to projected coordinate systems because UTM is a planar or projected coordinate system. And then down here, UTM, and then what is the datum that the UTM coordinate system, so what's the assumed shape of the globe? So we'll choose NAD 83, and then zone 1 north. Okay, and then we'll repeat the process. So in our results window, we would just recall the project tool, and then just change our input to our graticule, and then we'll name our output graticule UTM zone 1. Okay, so from the insert menu, we insert a new data frame. So let's rename this to UTM. Assuming the shape of the globe is NAD 83. And then we'll add our 2 layers to that data frame. Okay, so if we look at the properties of the layer now, the cylinder is a transverse mercator cylinder, so basically it's a cylinder on its side, and its central meridian is at -177 degrees. So remember, the zone is 6 degrees wide, so we're going from -180 on the western edge of the zone to -174 on the eastern edge of the zone. And the scale factor at the central meridian is actually 0.9996. So as we go east or west of the central meridian, our scale factor gets better and better and better, and it approaches 1, but it never quite reaches 1. So the worst scale factor possible in this UTM zone would be 0.9996 at the central meridian. And then the other thing that's kind of weird is at the central meridian, so at 177 degrees west, we arbitrarily have an X value of 500,000 meters. And then the latitude of the origin is 0 meters at the equator. So 0 meters at the equator. So that's the UTM coordinate system. The X is sort of a false X. That's why it's called a false easting. And it's arbitrarily given a value of 500,000 meters at the central meridian. And then the Y is given a value of 0 meters at 0 degrees latitude or the equator. So then we could turn on Alaska, and you can see it's very slanted because north-south is going to be at zone 1, which would be in this area here. And here's our graticule, so let me make that hollow. So north-south would be from 180 degrees, go 3 degrees to the east. That's the central meridian, so that's where north-south will be straight up and down. And then once again, we can use the go to XY tool, and we'll go to our longitude -177 and our latitude of, let's go to a latitude of 50 degrees, because if we went to the equator, we would be way south. And we'll put a labeled point there. So here is the central meridian -177 west. So right at that value of the central meridian of 177 degrees west, in the UTM coordinate system, you'll have an X value of 500,000. So if I go, there's 500,000 in the X. So if I go left of that, will be less than 500,000 meters. If I go right of 177, we'll have greater than 500,000 meters. And then once again, the Y value is how far north are we from the equator. So here we're 5,537,000 meters north of the equator. And then if I zoom to layer, and I go up here, I'm 7,776,468 meters north of the equator. So the Y value is always how far you are north of the equator, and the X value is always an arbitrary X value of 500,000 meters at the central meridian. Okay, so we could repeat the process and just use the results window. So we'll project graticule, and we'll project to a different UTM zone. So let's go to UTM Zone 6, which is Fairbanks is in UTM Zone 6. So 6 north. And we'll call that 6 north. And then just OK. And then we'll put that in a new data frame. Okay, so if we look at the properties of this layer, it is in UTM Zone 6 north. And you could count over, so zone 1 is 6 degrees wide, and it's -180 to -174. Zone 2 would be 6 degrees wide, so that would be 174 west to 168 west. So you could count over to zone 6. And zone 6, the central meridian is -147, so it would be from -144 to -150. So straight north in this UTM coordinate system will be at 147 degrees west. And at that location, the X value will arbitrarily be 500,000 meters. And at the location, the scale factor is the worst possible, and that's 0.9996. So if we go to the left or to the east of our central meridian, the scale factor approaches 1 as we go away from the central meridian. And once again, we can use the go to XY to put some points on our data frame. So I added 4 labeled points at the central meridian. So at that location, X is going to be 500,000 meters. And as we go north, we go further and further from the equator. So here we're 333 meters north of the equator. And up here, we're 8,883,000,000 meters north of the equator. But the X value is 500,000 at the central meridian, which is 147 degrees west. And if we're left of that, the X value will become smaller. And if we're to the right of that, the X value will be above 500,000. Okay, so we've got one more common coordinate system used in Alaska, and that's the state plane coordinate system. And I'll teach you that in the next video.